today, January 30th, we are going to discuss rational equations. I told you for that one section we were going to stop worrying about things that were points of discontinuity or excluded values. But today, we are going to add back in the idea of pretty much a restricted value extraneous solution type occurrence, all right? And what's going to happen is we're going to solve some equations, but some of our solutions won't actually work. It's kind of weird, all right? So let's look at this for just a minute. Let's say that I have x divided by 2 is equal to 1 divided by x. Okay? So this is a really basic rational equation. X divided by 2 is equal to 1 divided by x. The rules for rational equations are actually very simple. Multiply by the GCF, or the LCM, or LCD. Step 2, solve. Step 3, check solutions. And there's a way to check the solutions without having to go through the entire problem and check the entire solution. We can check it through a series of very carefully orchestrated rules that we've actually already learned. So the first thing we're going to do to get this equation where I have no denominators, I multiply by the least common denominator. And just like when we were working with addition and subtraction, it's the same concept. You want all denominators to share the same thing. But instead of getting new denominators and new fractions, we are getting rid of all fractions at the same time. So I'm going to multiply this entire equation by 2 and by x. Do you all see that? Okay. The 2 came from right there. The x came from right there. When I multiply by 2x on the left, I will be left with x squared. And when I multiply by 2x on the right, I will be left with 2. At that point, I would take the square root of both sides, and I would get x is equal to plus or minus the square root of 2. And when it says check solutions, we're not checking solutions like when we were little kids and we were learning Algebra 1 to plug it back in and see if it's the right number. The solution we're checking is whether or not we're allowed to use these numbers. You see, the square root of 2, if I were to substitute it into the equation on the left, plus or minus the square root of 2, that would give me a real number. On the right-hand side, where I have the x in the denominator, I could substitute that in because the only number that would be a problem would be 0. So I have now checked to make sure that both of my solutions are what are considered feasible or allowed to be used. So this is good. We have our solution, x equals plus or minus the square root of 2. So let's continue this discussion and let's look at something such as this. 10 divided by 6x plus 7 is equal to 6 divided by 2x plus 9. Okay. On the left-hand side and the right-hand side, is anything going to be factoring here? No. Now, a cool trick that you might remember is called the cross product. How many of you remember the cross product? Where essentially, if you're dealing with just what's considered a basic proportion, you take the denominator of the right and you multiply it by the numerator of the left side of the equation, and you take the denominator of the left side of the equation, you multiply it by the numerator on the right side of the equation. That would give you 20x plus 90 is equal to 36x plus 42. But to make sure we stay within the guidelines of the rules that we originally learned, which was step 1, multiply by the least common denominator, I'm going to show you what that would look like. So I was just showing that we could, in fact, use the least common denominator to get the exact same process. Solving that, you would subtract the 20x and the 42. You would end up with 48 is equal to 16x. Divide by 16 and you end up with x equals 3. Let's look at our solution. X equals 3. Would x equals 3 cause either 6x plus 7's denominator or 2x plus 9 as a denominator to ever equal 0? Nope. So this solution is acceptable. I'm going to give you a moment to try and solve this next one, and then I'll show you the answer. So negative 4 divided by 5 times x plus 2 equals 3 divided by x plus 2. Okay. So we are going to somehow solve this. So we did two ways. We actually ended up figuring out that we could have multiplied 5 times x plus 2 on both sides, and that would have ended up with this answer of negative 4 equal to 15, which doesn't make any sense. And if we had gotten that, you would have written no solution. The other answer you could have done is by cross product, and you would have ended up with x equals negative 2, but x cannot equal negative 2 because it would cause my denominator to be 0, and dividing by 0 is always undefined, and undefined is not allowed. Okay, so let's make it slightly trickier. These are kind of too easy. Let's do one that looks like more fun. Are you guys ready for more fun?
Yeah.
Me too. Okay. Let's throw in this question, and it looks like this. 2 divided by x plus 2 minus 1 divided by x is equal to negative 4 divided by x times x plus 2. Hopefully you'll notice right off the bat, you cannot do the cross product here, because they're not two ratios here. They're not two fractions. So since we can't do the cross product, we have to do the 3 order. 1, which is LCD. What was after LCD? Solve. What was after solve? Check. Now, overall, that's a really simple set, because LCD and solve is most of your work. Check is really just, do you notice any problems, okay? So let's do this one. What is the least common denominator of all 3 parts? Tell your neighbor, or think about it for a moment. And that answer is what, Kayla? That is correct. X times x plus 2. Remember that we are multiplying each term by x times x plus 2. And whatever is in the denominator that factors away or reduces away is fine. So for 2 divided by x plus 2, out of the x and x plus 2, what will be left? X. So this will be 2 times x. Minus 1 times, what, everybody? X plus 2 is equal to negative 4. Just negative 4?
Yeah.
There you go. Now we took what looked like a semi-difficult problem, or possibly an incredibly difficult problem, and we've gotten to this stage with it, right? Let's continue. Distributing the negative 1, we have 2x minus x minus 2 equals negative 4. What's 2x minus x? X. What's x minus 2 equals negative 4? Add 2 and you get x equals negative 2. How many solutions did I get? One solution. So I have done my least common denominator step. multiplied. I have now found all possible solutions. Kylie? And what do I have to do now? Check. Can I use negative 2 as a solution? Negative 2 times negative 2 plus 2. What's negative 2 plus 2? 0. Is 0 allowed?
No.
Nope. Therefore, the answer is no solution. So let's try this one. We are going to get the following. 5 divided by x squared minus 7x plus 12 minus 2 divided by 3 minus x equals 5 divided by x minus 4. This one is going to have a very interesting occurrence, and I want you to pay close attention. I'm going to start by factoring, because that's part of the LCD step, all right? So if I factor on the left, I have x minus 3 and x minus 4. I really wish that I had an x minus 3 and an x minus 4, because this middle step, it's giving me a problem, isn't it? Now, the other day I showed you this. If I had a negative y over x, that could be rewritten as negative y divided by x. You guys remember that? And then a couple of you asked the question, well, shouldn't you do it in both? And I had to describe that if you did it in the numerator and in the denominator, that would be two negatives, which makes a positive. So no. However, how about instead of doing it in the numerator, we just did it in the denominator? Could I do that? Yeah. As long as I move it to one of the two locations, right? Now watch this really cool thing that happens. I'm going to erase this so it's not in our way anymore. I'm using red. I'm going to change that subtraction sign to a plus sign, and then I'm going to change that to minus 3 plus x. I took the negative. I placed it in the next fraction. But instead of switching the numerator, I switched the denominator. Now, if I just reverse the order, now it's x minus 3 that I wanted. You can do that. That's allowed. It's pretty cool. Now I know my least common denominator is x minus 3 times. So I write it once out here. If you would like to write it next to each term, you can. It's going to cancel out the entire term on the left, so it's just 5. Plus, the x minus 3 and the x minus 3 will now cancel, and I'll have a 2 times x minus 4. But remember, x minus 3 and x minus 4 are still there. They only canceled for that term. 5 divided by x minus 4, the last rational expression, that cancels with the x minus 4, but the x minus 3 is still present. 5 times x minus 3. Please solve that quickly. And we have the answer of x equals 4. Are we done? No, now I must check. Is there going to be a problem with the x minus 3? Can 4 minus 3 work? Yeah, that works. What about 4 minus 4?
No.
Even though I have a solution, once again, is it an actual solution?
No.
No, it's not. So x cannot equal 4, so once again we have an answer of no solution. Remember, an answer we can solve for, but when we substitute it back into the denominators, if it causes the denominator to be 0, it's not an allowable solution, therefore it is no solution. If I had two solutions and one of them worked but one of them didn't, do I still have a solution? Yes, because the one that does work is still a solution. Let me give you another problem, and I want you to try this one all on your own.
Wait, hold on.
Yes, ma'am. So I want you to try this one on your own real quick. I will show you the answer, but I may not go through it. 10 divided by 2y plus 8 minus 7y plus 8 divided by y squared minus 16 equals negative 8 divided by 2y minus 8. Here's your hint. Factor first to figure out the denominators you want to work with. The answer is y equals 6.